Permutation is an ordered arrangement. Let's consider a set with elements S is equal to 1, 2, 3, and the following examples 1, 2, 3, 2, 1, 3, 3, 1, 2 are permutations. So an ordered arrangement of R distinct elements of set S is called as R permutation over set S. It is denoted by P of n comma R, which is n factorial upon n minus R factorial. So let's solve this problem. In a running race of 12 sprinters, each of the top 5 finishers receives a different medal. How many ways are there to award the 5 medals? So we can see this. This is a permutation of n factorial upon n minus R factorial. That is it is 5 permutation of 12 sprinters. Okay, so it is NPR or P of n comma R. So 12 factorial upon 7 factorial. So we look at this, we can say that there are 12 ways to award the first medal, 11 second, 10, 9, and 8. Okay, let's look at the next example. How many permutations of letter A, B, C, D, F, G, H contain the string ABC as consecutive substring? Now we can solve this problem here by considering ABC as one entity, and so the remaining characters are D, E, F, G, H. So there are 5 remaining characters and ABC as one character. So there are total 6 characters, and so we can have 6 factorial permutations, which is equal to 720. So the earlier was ordered arrangement, and the next is combinations, which is unordered arrangement. So the denoted by C of n comma R, which is equal to n factorial upon R factorial into n minus R factorial. So let's look at the first problem. How many different 5-card poker hands can be dealt from a deck of 52 cards? In the second problem, how many different 47 card poker hands can be dealt from a deck of 52 cards? So if you look at both the problems, here the first problem can be solved as 52C5 and the second as 52C47. Both the answers will be same. So then combinatorial proof is basically a proof that uses counting arguments to prove a particular kind of a theorem. So let's look at one more problem. Suppose that there are 9 faculty members in a mathematics department and 11 in CS department. How many ways are there to select a committee to develop a discrete mathematics course at a school if the committee is to consist of 3 faculty members from mathematics department and 4 from the computer science department? So there are 7 positions, and 3 positions are given to mathematics department and 4 positions are given to computer science department. So by combination rule and the product rule, we can select 3 positions in 9C3 ways from the total for mathematics department, and we can select the 4 positions for CS in 11C4 ways, and the product of the 2 will give us the total number. So this is a typical problem in discrete mathematics for combinatorics, that is circular sittings. So how many ways are there to sit 6 people around a circular table where sittings are considered to be seen if they can be obtained from each other by rotating table? So first place, the first person in the northmost chair, and there's only one possibility. Then place the other 5 people in the 5 factorial ways, so that is 120 ways. So by product rule, what we get is 120. There are 120 ways to make 6 people sit in a circular setting. So an alternative is basically we get 720 ways to sit the 6 people around the table. Okay, so and then there are 6 rotations, and so total we get is 120 ways. So both the ways we get the same answer. The next is basically the binomial coefficients. So binomial coefficients is basically expansion of the form of a plus b raised to 4 as NC0 a raised to 4 plus NC1 a raised to 3 and b raised to 1. So this is the expansion. So in general, x plus y raised to n is equal to summation nj. Nj is basically ncj, x raised to n minus j and y raised to j. The coefficient of a raised to 8, b raised to 9 in the expansion of 3a plus 2b. 3a plus 2b raised to 17. So here j value is basically 9. So what is the value of n? So n value is 17. What is value of j? So it is 9. What is value of x? It is 3a because it is x plus y. So 3a plus 2b. What is value of y? So it is 2b. So 17c9, 3a raised to a and 2b raised to 9. The binomial coefficients, few examples, that is a plus b square. So a square plus 2ab plus b square, a plus b cube, or a plus b raised to 4. All these are basically expanded using the concept of binomial coefficients. So if what is the coefficient of a raised to 9 into b raised to 3 in a plus b raised to 12? So the answer is 2 raised to 220, and this can be algebraically verified. The application of binomial coefficient is basically Pascal's identity. So Pascal's triangle, you might have printed it using a C program or a Python program. So this Pascal's triangle can be constructed as, so you can look here, they highlighted in blue. So 6c4 plus 6c5 will give us 7c5. So in this way you can look here, that is 2 plus 1 will give us 3, or this 2 plus 1 will give us 3, and that is how the Pascal's identity works for the binomial coefficient.